Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of the oblique lines. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now an oblique line is the one which happens to be inclined to both the reference planes, that is horizontal plane as well as the vertical plane. And due to the inclination of the oblique line with the two reference planes, so neither of the front view or the top view, so they are drawn parallel to the XY reference line, and the projections of the oblique line onto the horizontal plane and the vertical plane, they are going to reveal the apparent length of the line, and we will not be observing the true length of the line either in the front view or the top view orthographic projection. So we are required to use the principles of rotation of the line method in order to be able to develop the true length of the line in the front view and the top view, and the true inclinations of the line with the two reference planes. Here we have been provided with a real life situation into which a horizontal wooden platform is available with us, and the dimensions of this horizontal wooden platform, so they happen to be 2 meter width and 1.5 meter it is the depth of this particular platform. So 2 meter by 1.5 meter we have got this particular platform. So this is suspended through the hook using these 4 chains, and these 4 chains, they will be similar in a way that the length of each of the chain, it will be equal to each other. So we are required to evaluate the length of this particular chain when the distance between this particular hook and the platform happens to be 4.5 meters. So here we are going to use the scale of 1:50, that is 1 meter we are going to draw as 2 centimeter or 20 millimeter onto the orthographic projection. So here we will be first of all converting this real life problem into the orthographic projections of the oblique line, and once we draw the orthographic projections corresponding to this real life environment situation, then we will be using the principles of the rotation of the line to obtain the true length of each of these 4 chains and the angle of inclination of these chains with respect to the ground. So let us proceed with the construction of the orthographic projections corresponding to this real life situation. So we have got this XY reference line. So we know that we have got the dimensions of this wooden platform. So the dimensions of the wooden platform, they are marked as 2 meter by 1.5 meter. So since this is our front view orientation, so first of all we are going to draw the top view projections corresponding to this wooden frame. So we have got the dimensions of the wooden frame as 2 meter by 1.5 meter. So using a scale of 1:50, so we are going to draw a rectangular block over here which is going to represent the top projections corresponding to this particular wooden frame. So distance between points A and B and points C and D, it will be 40 millimeter, that is corresponding to 2 meter width of this particular block, and this depth, it happens to be 1.5 meter, that is the distance between points B and C. We can check points B and C, they are separated by a distance of 1.5 meter. Similarly, points A and D, they are also separated by a distance of 1.5 meter. So this rectangular construction in the top view projection provides us with the true shape projections of this particular wooden block. Why? Because this particular wooden block happens to be parallel to the ground. So since this is parallel to the ground, so we have obtained the true shape projections of this wooden block onto the ground, that is onto the horizontal plane. Now having obtained the true shape projections of this wooden block onto the top view projections, that is onto the horizontal plane. Now we also know that since there is a hook at the top which is at a height of 4.5 meters above this particular platform, so these four chains, they will be having equal lengths over there, because only then this block will become horizontal over here. So in order to maintain that this particular wooden block ABCD, it will be lying in the horizontal orientation. So the length of the chains HA, HB, HC and HD, they should be equal to each other. So now we have to locate the center point of this particular block, because this length, this length, this length and this length, they will all be equal to each other. That is HA in the top view, HB in the top view, HC in the top view and HD distance in the top view. They will all be equal. So having identified the location of this particular point H over here, so through point H we can draw a vertical projector line so that the location of point H dash can be located alongside this particular vertical projector line. Similarly, corresponding to the points A and D, we need to draw the vertical projector lines, and through the points B and C, we also need to draw the vertical projector line, such that the front view corresponding to the points A and D and similarly B and C can be located in the front view projection. So through A and D, you can check, we have drawn a vertical projector line and we assume that this particular platform, so we can assume that this is lying onto the ground. So if this is lying onto the ground or it is horizontal, so we can mark this point A and B over here onto the XY reference line. So here we are going to get, if we are going to look from this particular orientation, we are going to get projections corresponding to A and D, that is A dash and D dash, they will be lying over here onto this particular reference line. Similarly, projections of points B and C, they will be available with us onto the ground, that is onto the XY reference line over here. Now we also know that the distance between the hook, that is the vertical distance between the hook and this particular wooden platform, happens to be 4.5 meters, that is 90 millimeter orthographic length we are required to draw. So from this point we are going to mark a distance of 90 millimeter above the XY reference line or above the ground. Ground means this base of the wooden platform over here. So once we mark this distance equal to 90 millimeter, which is corresponding to 4.5 meters, we will be able to obtain the location of this hook in the front view. So H dash has been located, A dash, B dash, C dash and D dash points, they have been located. Now we can join these chains and we will find that this chain HA and HD, so these two chains, they will be overlapping with each other on one side, whereas the chains HB and HC, they will be overlapping on the other side of the location of this particular hook. So once we join this, so we are going to obtain H dash A dash over here, H dash D dash over here, both of them they are overlapping. Similarly, H dash B dash and H dash C dash, these two chains, they are also overlapping. Now with this, we have been able to convert this real life problem into the orthographic projections of the oblique line, where we can see that these projections, they are not parallel, that is HA, HB, HC, HD, and similarly H dash A dash, H dash D dash, H dash B dash and H dash C dash, they are all inclined with respect to the XY reference line. So all the projectors corresponding to these chains, so they happen to be inclined to the XY reference line. Now we will be using the fundamentals of the rotation of the line in order to evaluate length of these chains over there and the angle of inclination of these chains with respect to the ground. And since we know that all of these chains, they are similar to each other, that is, the chain lengths, they are equal, the chain inclinations with respect to the ground, they are also equal. So we will be picking up any one of the chain length over here. We can pick up either HA or HB or HC or HD, and whatever true length we are going to obtain for one of the chains, so the same true length will be available with us regarding all the other remaining three chains over here. So here you can check, we have picked up this particular chain HD over here. So this is one of the chains. So we have mentioned chains over here because it is similar with HA, HB and HC. So having picked up this chain HD, so we know that the top view projection corresponding to this chain HD, it is inclined with respect to the vertical plane. Similarly, H dash D dash, that is the front view projection corresponding to this chain, it happens to be inclined with respect to the horizontal plane. So we have got the perfect situation corresponding to an oblique line, and in order to obtain the true length of this oblique line or the oblique chain, so we need to remember that whenever the apparent length projection of the line in the plan, if it is parallel to the vertical plane, then if we draw the projectors through this projection line, we are going to observe the true length of this oblique line in the front view or onto the vertical plane. So here we have got the apparent length projection which is inclined to the vertical plane. Now what we need to do, we have to rotate this apparent length so as to make it parallel to the vertical plane. So what we are going to do over here, we have drawn a horizontal locus line through the point H so that we can rotate this line, that is apparent length projection HD, and make it parallel to the vertical plane. So we'll keep our needle point of the compass at point H and rotate this line HD in such a way, open the compass equal to HD distance, rotate point D and extend this curve up to the horizontal locus line which is emerging from the point H, and once this curve will intersect with this horizontal locus line which is passing through the point H, so this point of intersection, because this is the first rotation, so name of this point will be D1. So through this rotation we have been able to obtain the apparent length corresponding to the chain HD, HD1 over here. So this apparent length, now it has become parallel to the vertical plane. Now what we need to do, from this point we are going to draw a vertical projector line onto the vertical plane, and the point of intersection with the vertical plane, it will be providing us with the true length of this particular line or the chain in the front view. So from point D1 we are going to draw one vertical projector upwards up to the horizontal locus line which is emerging from the point D dash over here. So this is my point D dash. Through this is the horizontal locus line which is emerging from the point D dash, and wherever these two locus lines they intersect, we will be able to obtain the point D1 dash over here in the elevation. So the moment we obtain this point D1 dash in the elevation, now we are going to join this H dash point, that is the location of the hook point, with the D1 dash point using blue color line. So blue color line means that we have drawn the true line, and you can check we had drawn the blue color line while we were drawing the construction of this wooden block, because A, B, C, D in the top view, it was also representing the true shape of the wooden block, whereas the chain we had drawn with the red color, it means that this was the apparent length. right? So here we have marked h dash d1 dash as the true length, and having obtained this true length, we can also evaluate the angle of inclination of this true length with respect to the horizontal plane. And this angle of inclination of the true length, that is h dash d1 dash, with respect to the ground or with respect to the horizontal plane, it has been marked with angle theta over here. So angle theta has been evaluated and the true length has also been evaluated. Now we are going to validate that whether this true length that we have obtained in the front view, it is accurate or it is not accurate. So for that purpose, we need to evaluate the true length of this particular chain even in the top view. So in order to evaluate the true length of this chain in the top view, so we know that we will be able to obtain the true length of this chain in the top view only when the apparent length of the projection in elevation, it should become parallel to the horizontal plane. So whenever the apparent length projection of a line becomes parallel to the horizontal plane, so the projections drawn through these 2 points onto the horizontal plane will provide us with the true length of the line in the top view or onto the horizontal plane. So here we can see, once we observe that h dash a dash and h dash d dash, so these are the two chains which are available with us in the front view, right? So once we have got these two chains overlapping with each other, but these chains, they are available with us in the inclined orientation, that is the front view elevation projection corresponding to these two chains. They are not parallel to the horizontal plane, rather they happen to be inclined with respect to the horizontal plane. So what we need to do, we will be rotating this apparent length projection corresponding to these two chains h dash a dash and h dash d dash, such that these two projections, they should become parallel to the horizontal plane. So how we can do it? We will have our needle point as h dash, open compass is equal to the distance h dash d dash or h dash a dash, and then keeping our compass needle over here, open compass up to this radius, draw an arc and extend this arc till it meets the horizontal locus line which is emerging through the point of the needle point, that is h dash. So wherever this curve intersects with the horizontal locus line which is emerging from the needle point, so we obtain the points a2 dash and d2 dash. Why the numbering 2 is there? Because this is the second rotation. So having obtained these 2 points, now we can check. We have got the elevation projection line which is h dash a2 dash and h dash d2 dash. So this elevation projection line corresponding to these two chains, it happens to be parallel to the horizontal plane. And once we have got this particular apparent length in elevation parallel to the horizontal plane, now we will be drawing projectors through these 2 points a2 dash and d2 dash because they are overlapping. So from this, a vertical projector line will be drawn such that it should intersect with horizontal locus line emerging through the point A and horizontal locus line emerging through the point D over here, because two chains, they were overlapping. So the two true lengths we are going to obtain in the top view. So through a2 dash and d2 dash, you can check one vertical projector has been drawn downwards now. So once we draw this vertical projector downwards, so wherever this projector intersects with the horizontal locus line emerging through the point D, so the point D2 will be located over here. Wherever this vertical projector line, it intersects with the horizontal projector line emerging through the point A, so point A2 will be located. So point A2 is located over here, point D2 is located over here. Having located these 2 points, we can join the true length corresponding to this chain in the plan, that is HA2 and HD2. So HA2, it is the true length of the chain corresponding to the chain HA, while HD2, it is the true length corresponding to the chain HD. So now we are going to evaluate that the distance which we had obtained corresponding to the true length of the chain in the front view, which was H dash D1 dash. So this distance of H dash D1 dash must be equal to the true length of the chains which we have obtained in the plan, that is HA2 and HD2. So if these three blue lines that we have shown over here, which are representing the true length of the chain in the front view as well as in the top view, we will validate that the problem which we have solved using the principles of rotation of the line, it is drawn accurately. So H dash D1 dash must be equal to H D2 and it must be equal to HA2. So the true length of the chain we have evaluated, the inclination of the chain with the ground we had evaluated it in the front view projection. So this angle theta we had evaluated. So this way we have been able to evaluate the true length of the chain as well as the inclination of each of the chains with the ground. So this is all for today. So with this discussion, I hope that you would have understood about the procedure, how we can go about converting a real life problem into the projections of the oblique lines, and then using the principles of rotation of the line, how we can go about evaluation of true length of the line in the front view as well as true length of the line in the top view. And we have also evaluated the angle of inclination of the line with respect to the reference planes over here. So we'll be continuing with few more applications of projections of the oblique lines in the coming lectures. So thank you very much. Thanks a lot.